You see them on almost every street corner in every city. They're so common we barely even notice them anymore. But the humble fire hydrant, it's a true icon of city life, a silent guardian that's packed with some seriously clever engineering. So let's dive in and uncover the secrets hiding right there in plain sight. Because seriously, when you look at one of these, you're really only seeing the tip of the iceberg. What's happening above ground and, way more importantly, below the ground, well, that's a fascinating story of design, safety, and some really cool physics. Okay, so let's start with the basics. We're going to break down the parts that we can all see. It might look pretty simple, but trust me, every single component has a critical job to do. Right at the very top, you've got the operating nut. See how it's shaped like a pentagon? That's on purpose. It means it can only be opened with a special wrench that firefighters carry, which helps keep people from messing with it. Then you have the outlet nozzles, usually a big one for the pumper truck and a couple smaller ones for hoses, all protected by those super heavy-duty caps. And of course, there's the main body, or what they call the barrel, that tough, cast iron shell holding it all together. Now, you might be surprised to learn that not all hydrants actually stand tall like that. The pillar or post hydrant is what we all picture, but in places like historic downtowns or airports where you just can't have things sticking out of the ground, you'll find flush hydrants. They're installed completely underground, hidden beneath a little cover. They do the exact same job, but firefighters have to attach a temporary standpipe just to connect their hoses. And speaking of connections, this is where things get really cool. On more modern hydrants, you might see this. It's called a stores connection, and it is a total game changer. You see, old threaded caps had to be spun on just right, which takes time. This is a universal quick connect system. In a fire where every single second counts, this lets a firefighter lock on a massive hose in literally an instant. It's an amazing upgrade. Okay, so we've seen the outside. But the single biggest design choice for any fire hydrant is actually all about the weather. The number one enemy of a pipe full of water is freezing temperatures, and hydrants have evolved this brilliant solution to deal with it. This whole problem leads us to the two fundamental types of hydrants, wet barrel and dry barrel. It's pretty simple, actually. In warm climates where you don't have to worry about freezing, you use a wet barrel hydrant. It's always filled with pressurized water, ready to go. But in cold climates, that's where the dry barrel comes in. The main valve is located way down underground, below the frost line. This means the part of the hydrant you see is completely empty and dry, totally safe from freezing until the moment it's needed. And this one difference, wet versus dry, it changes everything. By putting that main valve so far underground in a dry barrel hydrant, engineers are basically using the earth itself as insulation to keep the water from freezing. It's genius. But as you can imagine, that solution also makes them way more complex and expensive to install and maintain than their simpler wet barrel cousins. So now let's go even deeper, because some of the most ingenious engineering is buried right under our feet, designed to protect both the hydrant and the entire city's water supply. Now, I know what you're thinking. That sounds completely wrong, doesn't it? Why on earth would you design a critical piece of emergency equipment to fail? Well, in this case, it's actually a feature, not a bug, and it's designed to prevent an absolute catastrophe. The solution is just brilliant. It's called a breakaway flange. Think of it like a safety fuse. If a car slams into the hydrant, this one specific piece is designed to snap off cleanly. So the top of the hydrant breaks away, but the main valve, deep underground, stays perfectly sealed. It's an intentional, sacrificial failure that prevents a giant geyser and protects the water main from a catastrophic break. Installing one of these things is a serious piece of civil engineering. After digging all the way down to the water main, they pour this massive concrete block, called a thrust block, right behind the base. This part is absolutely critical. It acts as an anchor, bracing the hydrant against the incredible constant force of that water pressure. We're talking a real-life example of Newton's third law. Without it, the hydrant could literally blow itself right out of the ground. All right, now for a fun fact you can actually use the next time you're walking around the block. Fire hydrants are color-coded. And believe me, those colors are not just for decoration. They're a vital piece of information for firefighters arriving on a scene. But first, you just have to appreciate the kind of pressure these systems handle. Before they ever go into service, hydrants go through what's called hydrostatic testing. They're often blasted with 200 pounds per square inch of pressure for hours on end. To put that in perspective, that is more than 6 times the pressure in a typical car tire. This insane test makes absolutely sure there are 0 leaks in the system. So once a hydrant is proven to be completely leak-free, it has to go through a flow test. This measures exactly how much water it can deliver. And according to national standards, that information is then painted right onto the hydrant itself for everyone to see. And here is the code. When a fire crew pulls up, a quick glance at the hydrant's caps tells them everything they need to know. Light blue, that's the jackpot, a Class A hydrant that can push out over 1,500 gallons of water a minute. Green is still really good, and orange is decent. But if they see red, they know immediately that it's a low-flow hydrant, and they might need to call for a second water source, fast. So, the next time you walk past a fire hydrant, hopefully you'll see it a little differently. It's not just some random piece of city furniture. It's a highly evolved, climate-aware, and incredibly tough piece of safety equipment, just standing there, ready at a moment's notice. It really makes you think, doesn't it? Our world is just filled with these hidden marvels, all with their own secret lives, just waiting for us to notice. What else are we walking past every single day without a second thought?